Hello. WhatsApp. ಇದು ನಂದು ನಂಬರ್ ವಾಟ್ಸಾಪ್ ಮುರಣಿದನು ಅಂದೆ ನಾನು ಕೊಂಚ ಮೆಸೇಜ್ ಕಡಪೆ ಜಸ್ಟ್ ಆ ನಂಬರ್. Good morning, everyone. In the last class, we were discussing non-deterministic finite state machines. Okay, we were discussing NDFSM. One second. Okay, just go through the example what we discussed in the previous class. This is the NDFSM. So here we have DFSM and NDFSM for the language where ABC ABB is a substring. Okay, so language over the alphabet ABC with substring ABC ABB. So this is the DFSM, and below we have NDFSM. See the difference between DFSM and NDFSM. Just compare how much complicated DFSM is compared to NDFSM. Okay, just I'll get back to you in 2 minutes. Okay, so here we have the NDFSM. Here we have the NDFSM. So as you can see from Q0, there are two competing moves for A. That is, one is from Q0 to Q1, another is from Q0 to itself. So this happens in NDFSM. So from one state on one symbol, you can have multiple moves. So in this example, from state Q0 on symbol A, you have two possible moves. You can select one of these two to process the input string. So there must be at least one path where your string gets accepted. Then string belongs to the language. If there is no path where string gets accepted, then string gets rejected. Okay, so this is the previous example discussed in the previous class. Okay, next we'll consider another example, multiple keywords. Okay, so here language over the alphabet a comma b, such that for each x comma y belongs to a comma b, w contains either ABBAA as a substring or BABA as a substring. So there are two possibilities. Okay, there are two possibilities. Either your string must have ABBAA as a substring, or it must have BABA as a substring. Okay. So this is the NDFSM. So there are two paths. One corresponds to the substring ABBAA and another corresponds to the substring BABA. Okay. So there are two paths. One which is corresponding to the substring ABBAA, as you can see. Another corresponding to BABA. And you know that substring means it can be anywhere, either in the middle or at the beginning or at the end. That's why before both of these, you can have any sequence of A's and B's, as well as at the end, you can have any sequence of A's and B's. That's why you have self loop at the beginning and at the end. So this substring has to be there anywhere in the string. Okay, substring has to be there anywhere in the string. Okay, so I hope this example is clear to you. Okay, so you know that language is over the alphabet a comma b, either ABBAA or BABA substring has to be there. Okay, so these are the two possibilities. Okay, so any doubts in this example? Is it clear to you? Any doubts? Okay, we'll move on to the next one, checking from the end. The fourth to the last character is A. The fourth to the last character is A. See here. So from the end, fourth character must be A. So this is first character from the end, second, third. This is the fourth character from the end, which has to be A. Okay, so fourth character from the end has to be A. So very simple. Fourth character from the end has to be A. Remaining characters can be either A's or B's. So at the beginning, you can have any sequence of A's and B's, but fourth character from the end has to be an A, which can be followed by any sequence of A's and B's. Okay, so this is the NDFSM for the language where fourth character from the end is A. So I hope this example is clear to you. Okay, I hope this example is clear to you. Just go through this example once again. So if any doubts, you can ask me. Okay, if any doubts, you can ask me. Okay, then we'll consider one important function which is called as epsilon function. Okay, we will understand this with examples. We'll understand this with examples. Okay, So here, let's consider this example. We'll come to know how to calculate epsilon of a state. So here, I want to calculate epsilon of Q naught. I want to calculate epsilon of Q naught. What is epsilon of Q naught? Epsilon of Q naught must include Q naught. So it's a set. Epsilon of a state is nothing but a set where that state must appear. So Q naught must appear. So Q naught has to be there. Then, then, then you need to include all those states which can be reached from Q naught by using epsilon transition. By using epsilon transition, which and all states can be reached from Q naught, all those states need to be included. So epsilon of Q naught must include Q naught first. Then as you can see, you can reach Q1 from Q naught by using epsilon transition. That's why you need to include Q1 also. Then you can reach Q2 from Q1. That's why even Q2 has to be included. Is it clear? Understood how to compute epsilon of a state? See, first I want to compute epsilon of Q naught. So epsilon of Q naught must include Q naught. It must include Q naught. Then from Q naught, using epsilon transition, you can reach Q1. That's why even Q1 has to be included. Then from Q1, you can reach Q2. That's why using epsilon transition. That's why even Q2 has to be included. So epsilon of Q naught is Q naught, Q1, Q2. Okay. Then I hope this is clear to you. Any doubts in this? Any doubts in computing epsilon of a state? Any doubts in epsilon function? Yes, please let me know. Yes, please let me know. Any doubts in this? Okay. Then you need to compute epsilon of Q1. So epsilon of Q1 must include Q1 first. Then from Q1, which and all states you can reach using epsilon? From Q1, you can reach Q2 using epsilon. That's why Q2 should be included in epsilon of Q1. Then, as you can see, from Q1, you can reach Q naught using epsilon transition. That's why even Q naught has to be included. That means epsilon of Q1 is Q1, Q2, and Q naught. Next, coming to Q2. What is epsilon of Q2? So epsilon of Q2 must include Q2 first. Then from Q2, you can reach Q naught using the epsilon transition. Then from Q naught, you can reach Q1 using the epsilon transition. That's why Q2, Q naught, Q1, all of them are included in the epsilon function of Q2. Then Q3, what is epsilon of Q3? It must include Q3. Then can you reach any state from Q3 using epsilon transition? No, you cannot reach any other state from Q3 using epsilon transition. That's why epsilon of Q3 is only Q3. Okay, I hope this is clear to you. Very important, because we are going to see some problems where without this concept you cannot understand or you cannot go ahead. Okay, cannot go ahead. So So first we computed epsilon of Q naught. So epsilon of Q naught includes Q naught, Q1, Q2. Epsilon of Q1 includes Q1, Q2, Q naught. Then epsilon of Q2 includes Q2, Q naught, Q1. All those which can be reached by epsilon transition. Then epsilon of Q3 is just Q3, because no other state can be reached from Q3 by using epsilon transition. Okay, so this is about epsilon function. Okay, next we have one problem. Algorithm is there, that is NDFSM to be converted to DFSM. So you know what is DFSM? It is the deterministic finite state machine. NDFSM means non-deterministic finite state machine. In DFSM, There is no confusion. From a given state, for a given input symbol, you know what is the next state. But in case of NDFSM, there is a confusion. For a given state, for a given symbol, there can be multiple next states. So it is better if it is possible to convert NDFSM to DFSM, because you know that NDFSMs can be developed very easily compared to DFSM. Then if it is possible to convert NDFSM to DFSM, what we can do is, for a given language, we can develop NDFSM first. Later we can convert it into DFSM. Okay. So now we are going to see the problem where we will be converting one NDFSM to DFSM. So this is the problem. Okay. One second. Let's see. Okay, this is the NDFSM. As you can see, there are epsilon transition. That's why this is an NDFSM. Now I want to convert this NDFSM to a DFSM. Okay. Now I want to convert this NDFSM to a DFSM. So first step, if you go through the algorithm, you'll understand. Okay, so let's discuss the algorithm later. First, I'll tell you the steps. Okay, first you need to compute. So here starting state is Q naught. So you need to compute epsilon of Q naught. You need to compute epsilon of Q naught. So let's do that. Epsilon of Q naught. So what is epsilon of Q naught? Can you tell me the epsilon of Q naught? What is it? Just tell me, compute and tell me what is epsilon of Q naught. Just now I explained how to compute epsilon of a state. Now for this example, tell me what is epsilon of Q naught. Consider this. What is epsilon of Q naught? What and all states can be reached from Q naught, including Q naught, using epsilon transition? Just tell me what is epsilon of Q naught. Yes. What is epsilon of Q naught? Just give me the answer. Give me the answer for epsilon of Q naught. That is the first step. That is the first step. That is the first step. So we need to compute epsilon of Q naught. So it is nothing but Q naught, Q1, Q3, is it? So many have given the answer. So you know that epsilon of Q naught must include Q naught. Then from Q naught you can reach Q1 using the epsilon transition. That's why Q1 should be included. From Q1 you can reach Q3. That's why Q3 should also be included. And there are no more states which can be reached by using epsilon. That's why epsilon of Q naught is nothing but Q naught, Q1, Q3. Okay, you don't know why others have given the wrong answer. Okay, so epsilon of Q naught is Q naught, comma Q1, comma Q3. Okay, Q naught, Q1, and Q3. Okay, that is epsilon of Q naught. Then that's about epsilon of Q naught. So this is the first step in converting NDFSM to DFSM. So this is called as S dash. So you know that S is equal to Q naught, which is nothing but the starting state of NDFSM. S is nothing but Q naught, which is the starting state of this NDFSM. Now I am going to compute the corresponding DFSM for this, equivalent DFSM for this. That's why the starting state of DFSM I'm calling as S dash, which is nothing but epsilon of Q naught. So starting state of DFSM is this Q naught, Q1, Q3. This is the starting state of DFSM. Okay. Then I need to compute the other states. So you know what is the starting state? We computed that. Next, so right now, so there is one more set which is called as set of active states. Let me write it here. Active states. Active states. Active states. This is also important. So initially, this set active states contains only one state, which is nothing but S dash, which is nothing but epsilon of Q naught. Okay, which is nothing but epsilon of Q naught. S dash is equal to this. So initially active states is having only the S dash, that is Q naught, Q1, Q3. This is the current set of active states. So you'll be adding more and more states as we proceed. So currently active states contains only one state, which is nothing but the starting state S dash. Now next step is to compute the transition for DFSM. Transition function has to be computed. So you know the notation, which is nothing but delta. So I'm going to write it as delta only because there is no way to type that particular symbol here. So, but we are going to call it as delta dash. Delta is for this NDFSM, delta dash for the DFSM, what we are going to compute. So now delta dash of, so we have not computed the transition for this, which is there in the set of active states. So we need to compute for that delta dash of Q0, Q1, Q3 on, as you can see, there are two symbols in the alphabet, 0 and 1. So first let me compute on 0. This is equal to, this is equal to, this is equal to so you need to compute this as epsilon closure of delta dash of Q0, 0. With this you have to compute. Okay. Then followed by union. So here we are going to compute delta of Q0, 0. Then followed by Q. Followed by epsilon of delta Q1, 0 union, we have next Q3, 0. So this is the formula for computing delta dash of Q0, Q1, Q3 on 0. So first, so this one is equal to what? So first compute the delta of Q0, 0. What is delta of Q0, 0? what is delta of q naught comma 0? Is it defined? So for q naught, transition is not defined on 0. For q naught, transition is not defined on 0. Okay. For q naught, transition is not defined on 0. Then, so that you can neglect. Then q1 on 0. What is q1 on 0? What is q1 on 0? Just tell me, what is q1 on 0? What is q1 on 0? See, I'm considering the second component. First component is null because for q naught there is no transition defined on 0. Second component q1 on 0. Q1 on 0. What is it? Tell me. So q1 on 0. Why it is q1, q2? It is just q2. Okay. So you are in state q1 on 0. You make a transition to q2. So you are in q2. Then what else you have? Epsilon of delta of q1 comma 0. Delta of q1 comma 0 is q2. What is epsilon of q2? You need to compute. What is epsilon of q2? Just tell me what is epsilon of q2. What and all states can be reached by you from q2 using epsilon transition? Just tell me what is epsilon of q2 quickly. So epsilon of q2 is q2. That's why q2 gets added here. Then one more is there, delta of q3 comma 0. So what is q3 comma 0? What is q3 comma 0? So q3 comma 0 is q4. q3 comma 0 is q4, right? As you can see, q3 comma 0 is q4. What is epsilon of q4? What is epsilon of q4? So what is epsilon of this q4? Just tell me quickly. What is epsilon of q4? So epsilon of q4 is q2 comma q4. So you can reach q2 using epsilon. That's why epsilon of q4 is q2 q4. So q2 union. So we have q2 union q2 comma q4. So which is nothing but q2 comma q4. So this is the new state for the DFSM q2 comma q4. Okay. So q2 comma q4 is the new state for the DFSM. So that's why you need to add that q2 comma q4 to the set of active states. Whether this q2 q4 is appearing in active states, no. That's why q2 comma q4 should be added. So q2 comma q4 should be added to the set of active states. Okay, q2 comma q4 should be added to the set of active states. Yes, now we have two states in the active state. Okay, now for the first state we computed delta dash of q0 q1 q3 on 0. Okay, next we need to compute delta dash of q0 q1 q3 on 1 instead of 0. Next we need to compute on 1. So let's do that. Okay, so to compute this, okay, 1 second. Okay, so let me write it, no problem. So I need to compute delta dash of q0 q1 q3 on 1. q0 q1 q3 on 1, which is nothing but epsilon of delta of q naught comma 1 union epsilon of delta of q 1 comma 1 So let me write. So I want to compute delta dash of q naught comma q1 comma q3 on 1 which is equal to which is equal to which is equal to which is equal to epsilon of delta of q naught comma 1 union epsilon of delta of delta of q1 comma 1 followed by union of epsilon of followed by union of epsilon of what is it epsilon of delta of q 3 comma 1 okay I'm writing this much. Now you need to compute. So epsilon of delta of q naught comma 1 q1 comma 1, then you have q3 comma 1. Okay, so let's do the computation. So first so what is delta of q naught comma 1? What is delta of q naught comma 1? What is delta of what is delta of q naught comma 1? What is delta of q naught? What is epsilon of q naught comma 1? Just tell me quickly. It is q naught comma q3. Okay, so you need to compute epsilon of q naught as well as epsilon of q3. So what is epsilon of q naught? Already computed here. The epsilon of q naught is nothing but q naught q1 comma q3. Then what is epsilon of q3? What is epsilon of q3? See, you need to be fast. It is it complicated? Tell me quickly. Otherwise, I cannot complete even one problem today. So what is epsilon of q3? What is epsilon of q3? So you know that we are computing delta of q naught comma 1. So from q naught, there are two possible transitions. From So from Q naught, you have two possible transitions on one. One is to Q naught itself, another one is Q3. So delta of Q naught comma 1 is nothing but Q naught and Q3. Q naught and Q3. Now tell me what is, so you know what is epsilon of Q naught? Epsilon of Q naught is Q naught, Q1, Q3. Next, you need to compute what is epsilon of Q3. Tell me what is epsilon of Q3. Tell me what is epsilon of Q3. What is epsilon of Q3? So epsilon of Q3 is nothing but Q3 itself, because no other state can be reached from Q3 using epsilon. That's why epsilon of Q3 is Q3 itself. Anyhow, Q3 is already a part here. You need not consider it once again. Okay. Q3 is already a part. That's why you need not consider it once again. Then union delta of Q1 comma 1. What is Q1 comma 1? Any transition defined on Q1 comma 1? Do you have any transition defined on Q1 comma 1? What is the Q1 on 1? What is there any transition? There is no transition for Q1 on 1. That's why you need not consider this. This gets eliminated. Then Q3 comma 1. Whether do you have any transition on Q3 comma 1? Is there any transition on Q3 comma 1? There is no transition on Q3 comma 1. That's why both of these are eliminated. That's why what remains is Q0, Q1, Q3. So whether this Q0, Q1, Q3 should be added to the set of active states. Q0, Q1, Q3, should it be added? It need not be added because it is already a part of set of active states. Okay. That's why this is not a new state. This is already existing in set of active states. That's why this need not be added to the set of active states. Okay, is this much clear to you? Is this much clear to you? Is this much clear to you? Okay. Now we started with S dash, which is epsilon of Q naught. Okay, which is nothing but Q naught, Q1, Q3. Now we computed the transition for Q naught, Q1, Q3 on 0 as well as 1. Now we need to consider the next state in the set of active states, which is Q2, Q4. So next we need to compute delta dash for Q2, Q4 in the same way. So what I'm doing is I'm keeping only the required part. The computation part I'll erase. Okay. So you know that. So delta of Q0, Q1, Q3 is equal to this. I'm going to keep only that. Okay, only that I'll keep. Rest I'm eliminating. Okay. Then here also you know that delta dash of Q0, Q1, Q3 on 1 is nothing but equal to this. I'm going to keep only that. The computation part I'll discard because I don't have sufficient space here. Only this part I'm going to keep. Okay. Yes. Next, I'm going to consider Q2, Q4. So let me compute delta dash of Q2, Q4 on 0. Let me compute delta dash of Q2, Q4 on 0. Okay. Q2, Q4 on 0. So what is the formula? It is nothing but epsilon of, so you can use the symbols delta. I'm not having that symbol here in this editor, that's why I'm writing delta. Actually you need to write that symbol itself. Delta of Q2, 0 union epsilon of delta of Q4 comma 0, like this. Q2 comma 0, delta of Q4 comma 0. Now can you tell me the answer for this? This is equal to what? So first, delta of Q2 comma 0. What is Q2 comma 0? Is it defined? Is it defined? Q2 on 0. So that transition is not defined. That's why this gets eliminated. This gets eliminated. What is delta of Q4 comma 0? What is delta of Q4 comma 0? What is delta of Q4 comma 0 is Q5. As you can see, Q4 on 0, there is a transition to Q5. Okay, what is epsilon of Q5? What is epsilon of Q5? What is epsilon of Q5? Tell me. What is epsilon of Q5? Just give me the correct answer. Don't simply go on giving the answer. What is epsilon of Q5? What is epsilon of Q5? So Q5 has to be there. You can reach Q4 using epsilon. That's why Q4 has to be there. From Q4, you can reach Q2. That's why even Q2 has to be there. So epsilon of Q5 is nothing but Q2 comma Q4 comma Q5. So this is epsilon of Q5. Okay. So which is nothing but delta dash of Q2 Q4 on 0. So as you can see, this is a new element. That's why it should be added to the set of active states. So this becomes a part of set of active states. Okay, now I'm going to keep only the required part. So this is equal to this. Okay. So Q2, Q4, Q5 is a new element of active states. So next step is to compute delta dash of Q2 comma Q2 comma Q4 Q2 comma Q4 on 1. So this you have to do next. Q2 comma Q4 on 1. Okay. So how to do that? Epsilon of delta of Q2 comma 1 union epsilon of delta of Q4 comma 1. So we need to compute this equal to equal to what you have to write. Okay. This is equal to what? Tell me. Delta of Q2 comma 1. What is delta of Q2 comma 1? Q2 of Q2 comma 1 is nothing but Q5. Q2 comma 1 is Q5. What is epsilon of Q5? What is epsilon of Q5? What is epsilon of Q5? Just tell me. What is epsilon of Q5? Epsilon of Q5 is Q2, Q4, Q5. So you need to add Q2, Q4, Q5. Then this has to be, you need to perform union operation with, what? Delta of Q4, 1. What is Q4, 1? Q4, 1 is what? Q4, 1 is what? Q4, 1 is Q1. What is epsilon of Q1? What is epsilon of Q1? What is epsilon of Q1? Epsilon of Q1 is Q1, Q3. So union Q1, Q3. Union Q1, Q3. So what is the new set then? What is the new set? New set is Q1, Q2, Q3, Q4, Q5. So you need to add it to the set of active states. Q1, Q2, Q3, Q4, Q5. So this is the new active state. So this is equal to this. So let me add it to the set of, let me add it to the list here, delta dash. Okay. So now we have computed transitions for Q2, Q4 also. Next step is to compute transition on Q2, Q4, Q5. So you need to compute delta dash on Q2, Q4, Q5. Okay. Delta dash of Q2, Q4, Q5 on 0. You need to compute this first. This is equal to what? Epsilon of delta of Q2, 0 union of epsilon of delta of Q4, 0, which is followed by union of epsilon of delta of Q5, 0. This is equal to, you have to compute. Okay. So first you need to compute delta of Q2, 0. What is delta of Q2, 0? Just tell me, what is delta of Q2, 0? Yes, what is delta of Q2, 0? What is delta of Q2, 0? Yes. Answer me quickly. Delta of Q1, 0. What is it? Just tell me quickly. Why you are taking this much time? Tell me quickly. What is delta of Q1, 0? So delta of Q2, right? Delta of Q2, 0. So we need delta of Q2, 0. Okay, not Q1. Here we have Q2. So delta of Q2, 0. Is it defined? It's not defined. You can skip it. Then delta of Q4, 0. Okay, what is delta of Q4, 0? Q4, 0 is Q5. Next, you need to compute epsilon of Q5. What is epsilon of Q5? Epsilon of Q5, you know, it is Q5, Q4, Q2. So that you need to add. So Q2, Q4, Q5. This gets added. And union with the next component. What is it? Delta of Q5, 0. What is Q5, 0? Q5, 0. Is it defined? For Q5 on 0, transition is not defined. That's why that gets or that becomes null. So this what remains Q2, Q4, Q5. Whether this is already there in the set of active states, Q2, Q4, Q5 is already there. That's why you need not add this to the set of active states. So just to add this to the set delta dash. Okay, so delta dash, this is one more. Okay, this is Q2, Q4, Q5 on 0 is nothing but Q2, Q4, Q5. Okay. Okay, already defined that is, that's why you need not add. Next, you need to compute delta dash of Q2, Q4, Q5 on 1. This one has to be computed Q2, Q4, Q5 on 1, which is nothing but epsilon of delta of Q2, 1 union epsilon of delta of Q4, 1 followed by union of epsilon of delta of Q5, 1. So what is it? Delta of Q2, 1. What is delta of Q2, 1? What is Q2, 1? What is delta of Q2, 1? What is it? Tell me quickly. Yes, give me the answer. Others also. What is delta of Q2, 1? Q2, 1. What is it? It is Q5. So Q2, 1 is Q5. What is epsilon of Q5? What is epsilon of Q5? You know that is Q2, Q4, Q5. So you need to add Q2, Q4, Q5. Okay, this has to be union with delta of Q4, 1. What is Q4, 1? What is Q4, 1? One second, we are still in the middle. Okay, we are still in the middle. Okay, we have not completed this step. We need to compute delta of Q4, 1. What is Q4, 1? Okay, what is Q4, 1? Q4, 1 is Q1. So here delta of Q4, 1 is Q1. What is epsilon of Q1? 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 It is Q1, Q3. So union, you have Q1, Q3. Next, union with delta of Q5, 1. Delta of Q5, 1, is it defined? Q5, 1, is it defined? No. For Q5, there is no transition on 1. That's why it is 5. So what remains is Q1, Q2, Q3, Q4, Q5. Q1, Q2, Q3, Q4, Q5. So whether this is already there in the set of active states Q1, Q2, Q3, Q4, Q5, so it is already there. That's why you need not add it to the set of active states. So I'm going to add it to delta dash. Okay. Okay, this is nothing but delta dash of Q2, Q4, Q5 on 1. Next, so we considered Q2, Q4, Q5. Next, we need to consider this state Q1, Q2, Q3, Q4, Q5. We need to compute delta dash for that. Okay, so delta dash of Q1, Q2, Q3, Q4, Q5 on 0, which is equal to epsilon of delta of Q1, 0 union epsilon of delta of Q2, 0. Q4, 0 union of so so yes. So we were discussing this. So first we have delta of Q1, 0. What is Q1, 0? So delta of Q1, 0 is Q2. Q2. What is epsilon of Q2? Epsilon of Q2 is nothing but Q2 itself. Epsilon of Q2 is equal to Q2 union. We have Q2, 0. Second, we considered Q1, 0. Next, we have Q2, 0. Q2, 0 is not defined. Next, we have Q3, 0. Q3, 0 is Q4. What is epsilon of Q4? It is Q2.
Sir, screen is not visible.
Okay, okay. So here we were doing Q1, 0 is Q2. Epsilon of Q2 is nothing but Q2. Next, Q2, 0 not defined. Next, we are at Q3, 0. Q3, 0 is Q4. What is epsilon of Q4? It is Q2, Q4. So we have Q2, Q4 like this. Then union of Q2, Q4. Then we have Q4, 0. What is Q4, 0? Q4, 0 is Q5. Q5. What is epsilon of Q5? Q5, Q4, Q2. So we have Q2, Q4, Q5. Okay, then union of we have Q5, 0. Q5, 0. Is it defined? No. So we have only this much. So what is the union? It is Q2, Q4, Q5. Q2, Q4, Q5, as you can see, it's already there. So you need not include it once again. So this is equal to set Q2, Q4, Q5. So you get this. Okay. Then we are going to remove this. I'm going to keep only the necessary thing. So we get this. So we have this Q2, Q4, Q5. Okay, Q2, Q4, Q5. Next, we need to compute. So I hope all of you are following. Is it clear or any doubts you have? Is it clear to you? Any doubts? If any doubts, please let me know. Okay, next we need to compute delta dash of Q1, Q2, Q3, Q4, Q5 on 1. So delta dash of Q1, Q2, Q3, Q4, Q5 on 1, which is equal to epsilon of delta of Q1, 1 union epsilon of delta of Q2, 1 union of epsilon of delta of Q3, 1, which is followed by union of epsilon of delta of Q4, 1 union of epsilon of delta of Q5, 1. Okay, so we have to do this. So first Q1, 1, what is it? Q1 on 1. So it's not defined. Next Q2 on 1. Q2 on 1 is defined. Q2 on 1 is Q5. What is epsilon of Q5? Q5, Q4, Q2. So we get Q2, Q4, Q5 like this. Union. Next we need to consider Q3 on 1. Q3 on 1 is not defined. Q4 on 1. Q4 1 is Q1. Q4 on 1 is Q1. What is epsilon of Q1? Q1, Q3. So we get Q1, Q3. Okay. Then so Q4, 1 is done. Next Q5, 1. So Q5 on 1 is not defined. That's why what remains is Q1, Q2, Q2, Q3, Q4, Q5. Q1, Q2, Q3, Q4, Q5, which is already there in the set of active states. That's why no new active states are added now. Okay. No new active states are added. So now if you see this set of active states, it is complete now. Because there is for every state in the set of active states, we have computed the delta dash. First one 0, 1, second one 0, 1, third one 0, 1, fourth one 0, 1. So there are 4 states. So for all of them, we have computed the delta dash. So that's why this completes the problem. Now we have the DFSM, which is equivalent to this NDFSM. Now we have the DFSM, which is equivalent to this NDFSM. Now next step is to draw that DFSM. Draw that DFSM. So for drawing, you need to know which is the initial state, which is the accepting state. Transitions are anyhow early state here. delta dash are the transitions corresponding to DFSM, which is equivalent to this NDFSM. So S dash is nothing but the starting state, which is that Q0, Q1, Q3. The first one is the starting state. So let me draw one at a time. So first one, Q0, Q1, Q3. Okay, this is the starting state. Okay. So this is the starting state. Okay. So starting state, you must indicate it with an incoming arrow. So there must be an incoming arrow for the starting state. So this is the starting state. Now, which are the final states? So you know that here final states are Q2, Q4 and Q5. So in which and all states you have either Q2, Q4, Q5, they are final states. So in the first one, we don't have Q2, Q4, Q5. That's why this is not the final state. Here we have Q2, Q4. That's why it's a final state. Here we have all of them. That's why it is a final state. Here we have all of them. That's why this is also a final state. So these three are final states. So wherever you have any of these three are going to be the final states. Now let's draw those states. So let me call this as or else we can give another name to that. Okay. So these are all accepting states. That's why you need to put a double circle around them like this. These are all accepting states. So we have Q2, Q4. So we have Q2, Q4 one state. Then we have Q2, Q4, Q5. We have Q2, Q4 and Q5. This is another state. Okay. Then we have one more state, which is the last one. Q1, Q2, Q3, Q4, Q5. Okay. So Q1, Q2, Q3, Q4, Q5. So these are the states of DFSM. Now we need to complete the transition. So you can give some other names also. You can substitute for this. You can use A, B, C, D, like that. You can do something that you need to mention if you are doing. Okay. Then delta dash of 0, where it goes. I hope it's clear to you. So here on 0 we make a transition to which one? On 0. So on 0 we are making a transition to Q2, Q4. Okay, this is the transition we do on 0 from Q2 to Q4. Okay. Not Q, sorry. So we are in state Q0, Q1, Q3. On 0 we make a transition to Q2, Q4. Okay, that is on 0. We need to mention that. So on 0 we are making a transition to Q2, Q4. Then on 1 we are making a transition to itself. Q0, Q1, Q3 means self. So on 1 there is a transition to itself. Okay, let's do that. So this is the transition to itself. Then let's consider Q2 comma Q4. So Q2 comma Q4 on 0 there is a transition to Q2 Q4 Q5. So from here there is a transition to this Q2 Q4 Q5. Okay, from here we have a transition to Q2 Q4 Q5 on 0. On 0 there is a transition to Q2 Q4 Q5. Then is it Q2, what is that Anvil? Q2 A4, I didn't understand. What is it? Q2 Q4 on 1 is to Q1 Q2 Q3 Q4 Q5. So next we have this transition. Okay, that is Q2 Q4 on 1. Next we need to consider Q2 Q4 Q5 on 0. It's a self transition. Okay, it's a self transition. So on 0, then Q2 Q4 Q5 on 1 is Q1 Q2 Q3 Q4 Q5. Okay, so we get okay. So this is the transition on Q2 Q4 Q5 on 1. Okay, on 1 we have this transition. Then next last state Q1 Q2 Q3 Q4 Q5 on 0. Here on 1 it's a self loop. So first let me draw the self loop. This one. Okay, so on 1 we have the self loop, and on 0 there is a transition to Q2 Q4 Q5. Okay, on 0 we have the transition from transition to Q2 Q4 Q5 like this. Okay, so this completes the conversion from NDFSM to DFSM. So this is the NDFSM. This is the corresponding DFSM. Okay. So just compare. See here, Q0, Q1, Q3 all are equal actually. That's why we have one state for that. Then Q0 on 1, it is to Q1 and Q3. So both are there in this, to Q0 and Q3. Then Q1 on 0 to Q2. So Q1 on 0, there is a transition to the state which contains Q2. Then Q2 on 1 to Q5. Q2 on 1 to Q5. So there is a transition to the state which contains Q5. Okay. Then Q4 on 0 is Q5. So Q4 on 0, there is a transition to the state which contains Q5. Then Q4 on 1 is Q1. Q4 on 1, there is a transition to the state which contains Q1. Okay, like that we can understand. Q3 on 0 is Q4. Q3 on 0, there is a transition to the state which contains Q4. Similarly, if you consider Q3 here, there is a transition to the state which contains Q4. So this is the DFSM corresponding to the NDFSM. Is it clear to you? Any doubts in this? Any doubts? Very important problem for the exam. It will be asked for 10 marks like that. Is it clear, or do you have any doubts in this? Is it clear, or do you have any doubts? Okay, no doubts. Okay, let me call the attendance. Sushmita, Adarsh,
Present, sir.
Aishwarya,
Present, sir.
Akshata,
Present, sir.
Amal,
Present, sir.
Anvit,
Present, sir.
Archana, Ashika, Ashwat,
Present, sir.
Atufa,
Present, sir.
Atufa, Aisha,
Present, sir.
Bhakti, Bhakti, Chirag,
Present, sir.
Hariprasad, Hariprasad, Harshit,
Present, sir.
Ibrahim,
Present, sir.
Kaushik,
Present, sir.
Azi,
Present, sir.
Manisha,
Present, sir.
Mohit,
Present, sir.
Lavanya,
Present, sir.
Faizan,
Present, sir.
Taik, Taik, Hisham, Maulya,
Present, sir.
Nida,
Present, sir.
Pooja,
Present, sir.
Prajwal,
Present.
Pranav, 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 Prasad,
Present, sir.
Prashanti,
Present, sir.
Pratiksha,
Present, sir.
Rifa,
Present, sir.
Rohan, Rohan, Roshni,
Present, sir.
Sahana, Sai Niketan, Angir,
Present, sir.
Rafa,
Present, sir.
Aranya,
Present, sir.
Chaitra,
Present, sir.
Chesta,
Present, sir.
Sriraksha,
Present, sir.
Shweta,
Present, sir.
Siddharth,
Present, sir.
Neha,
Present, sir.
Surya, Surya, Saurav,
Yes, sir.
Srilal,
Yes, sir.
Srijit,
Yes, sir.
Suman,
Present, sir.
Sumant,
Present, sir.
Sunit,
Present, sir.
Sushma,
Present, sir.
Sushmit,
Present, sir.
Sushmita, Sushmita, Varshita, Hima,
Present, sir.
Sridhar,
Present, sir.
Samash,
Present, sir.
Amrin,
Present, sir.
Ashiruddin, Tania,
Present, sir.
Ridwan, Ridwan,
Present, sir. Present, sir.
Sir, after for present.
hmm?
After for present.
1 second.
Sir, Sahana present.
Sahana present. Okay. Then Sahana present. Okay. Then who else is present? Tell me quickly. That's it, right? Yes. So how many are present? 53 are present. Okay, 53 are present. Okay, I hope you understood this. Okay, we'll consider one more problem in the next class. Okay, you can leave now. Thank you.